let's talk about our properties. These are properties of real numbers. And this is what we're using when we eventually start solving for equations. So some of them are going to seem very straightforward and good on that. And others we're just going to talk about a little bit. So let's start with the first of our properties, and that is the reflexive property. And that tells me that any real number is equal to itself. I am equal to myself. So a numeric example might be something like, give me a number. What am I thinking? 7. I know 7 will always equal itself, 7. An algebraic example is any x will equal x. So when we end up with equations and we have x on one side and then we end up with x on the other side, that is something that will always be true. So our next one, we're on with symmetric property. And that symmetric property, and I'm hoping you think about symmetry. What does that bring to mind? When I think of symmetry, I think of pretty photos that are mirror images of each other. I think of things in nature that are mirror images of each other. Mathematically speaking, this is telling us, so we're here, if I have these two values A and B and they're equal, then boop, if I flip them, that is still a true statement. So mathematically, we could say something along the lines of, if 3 plus 4 is 7, then what else must be true? 7 must equal 3 plus 4. And that's our symmetric property. And here, for an algebraic example, we could say something along the lines of 6 plus y equals 2 is an equivalent statement to 2 equals 6 plus y. So that takes us to, we've got reflexive, we've got symmetric, and we've got transitive. And with transitive, we're thinking there's a link. Transitive, and I'm going to write this over here so that it's clear. If A equals B and B equals C, where's my link? B's my link. Oh, it went on top of A. Let's try that again. B is my link. And so if A equals B and B equals C, then A and C must be equal. So what's a numerical? Let's do the same. If 3 plus 4 equals 5 plus 2, and 5 plus 2 equals 7, what's my therefore? And what's my link? My link is this. Therefore, 3 plus 4 has to equal 7. And our transitive is the same from an algebraic standpoint. If I had 3 plus x equals 5 plus 5, and 5 plus 5 equals 7 plus y, then my conclusion, where's my linkage? There's my link. My conclusion is that 3 plus x has to equal 7 plus y. And here we have a distorted description of our transitive property. Kerosene is fuel. Fuel is Red Bull. Therefore, kerosene is Red Bull. So now we're on to the substitution property. And that's telling us if I have two values A and B and they're equal, then I can replace B anywhere where I see an A, and I would still have a true statement. It's like if I have a dog and my dog's name is Penny. So if I said, I'm taking my dog to the vet, that should be the same statement as I'm taking Penny to the vet because my dog equals Penny. So I can replace those two with each other and still have a true statement. So for our purposes, what does that look like? That looks like if I have 7 plus 3, anywhere I have that expression, 7 plus 3, I can replace it with 10. And here, if I have x equals 4, and I have this expression, x plus 5, I can replace that with 4 plus 5 and still have a true statement. Now, our next two properties are related. You'll see one is the additive identity, whereas the other is the multiplicative identity. Both of them are saying, so for additive, what number can I add to any real number and still get that same number? What can I add to any number and still get that same number? And that would be, you are correct, 0. So here it would be, for example, 4 plus 0 will always give me 4. I'm going to throw in 2 variables. xy plus 0 will always give me xy. That is our additive identity. So the additive identity is really 0. If I add 0 to any real number, I'm going to get that same number as a result. Multiplicative. So now, same idea, but now we're asking what number do you multiply to any real number and still get that same number? And you'll notice here, it's 1. So 4 times 1 will always result in that same number coming out. Here, xy times 1 will always give me that same number at the end. So the next two are also related, but now the question is, what number can I add to any real number and get that additive identity as a result? So meaning, what number can I add to any real number and get 0? So we'll see here, if I add the opposite of A to itself, it always results in 0. So if I have 5 and I add to it, its opposite, -5, that will result in 0. And if I have an x, what I would add to it is its opposite, -x, and that results in 0. So multiplicative, what are you thinking? So now it's saying, what number do I multiply to any real number and end up with the result of 1? And that would be the reciprocal. So here, if I have some number A, if I multiply it by its reciprocal, 1 over A, that would result in 1. So that would be 6. What do I multiply to 6 to get 1? 1/6. That is the multiplicative inverse in action. And here, what do I multiply to x to get a result of 1? Its reciprocal, which is 1 over x. Now, multiplication by 0 should be intuitive to you. A times 0 is 0. So if I take some number 7 and I multiply it by 0, it's 0. If I take any real number x and multiply it by 0, it's 0. Nice. So now we've got 3 properties left. So one of them, we'll start with our distributive property, means if I have a number outside of my parentheses and I multiply it to the sum or difference of a quantity. I'm going to write it here so it's bigger. Multiply to the sum or difference of a quantity. I have to share. So that A has to share itself with each term in the parentheses. So that would result in A times B plus A times C. And the same happens if I have the difference of B and C. I still have to share. Distributing is all about sharing. So that gives us AB minus AC. So in action, we'll see, for example, if I have 4 times the sum of 3 and 2. Well, what does that look like? I'm going to have to share my 4. I have to share the 4 to the 3 and to the 2. So that gives us 4 times 3 plus 4 times 2. Because we share when we care. And then the same would happen if this were subtraction. And in algebraic terms, and you'll notice, just for notation purposes, even though we shared the x to both the y and the 2, we wrote the last terms as 2 times x. Even though 2x and x2 are the same, the constant comes before the variable. All right, so associating. When I think associative property of equality, that's grouping. Who do you associate with? Who do you group yourself with? And that just means if I have addition or multiplication, the associative property holds. So again, I'm going to bring this down to the bottom. So if I had this statement, which obviously is true, it's identical, the associative property is telling me this would still be true regardless of which 2 terms we take the sum of first. So in parentheses, a plus b plus c should equal a plus, in parentheses, the sum of b and c. And the same thing happens when I'm working with the associative property of multiplication. If I take the product of AB and then multiply it by C, that's going to result in the same numerical value as if I multiplied A to the product of B and C. And seeing that numerically would look like this. And algebraically looks like this. All right. And then here's the last one, and that's our commutative property. And again, the associative is who do you associate with? Who do you group yourselves with? Commutative, I think about commuting, moving from one place to the next, rearranging, like a little car. Boop. So if I'm thinking about the commutative property with respect to addition or multiplication, it will hold. A plus B will equal, then I can flip them, right? They commute, they move, they switch places. A plus B equals B plus A. That is not the symmetric property, people. That is not the symmetric property. A plus B equals B plus A would be the same as saying 2 plus 6 is the same sum as 6 plus 2. 2 times 6 is the same product as 6 times 2. And here I could say x times, let's do x plus y, it's going to equal the same as y plus x. And here, same, xy is going to equal the same as yx.